on this video we'll start the implementation part, and I'll be dividing the implementation into three different parts. So in first we will be implementing the collaborative filtering system, on another we will be implementing content based filtering, and on the third one we will be implementing the hybrid based system, which is a combination of collaborative and content based filtering system. Okay, so the very first thing that I want you to do is you have to install some library, because I do not have data currently, but I can download it from Kaggle, but I want to use the data set that scikit-learn already provides. So what you can do is just copy this line and you can open the Anaconda prompt, okay, and just paste this. Okay, and since I have already done, it will tell that requirement already satisfied, but for you, you must install this to use the dataset that I'm using for this implementation. And I mean, you can use any data type which has user ID, item ID, and rating. Okay, it's not that you have to use this the data set. I mean, just make sure the implementation is accordingly changed, I mean based on the data you are using. Okay, so it will take some time for installing. Okay, since I had to wait for 5 minutes to get it installed. I mean, this is not like a you know simple libraries. It takes some time, and it will download some requirement file for when you will be using it for first time. So I'm just closing it because I have already done. So just make sure that you install this, otherwise it will throw an error. And just to let you know guys, that pip install is deprecated, so it will won't work. I have tried myself, so that's why Conda is not deprecated yet, this one, so you can use it to install. Okay, so let's move to the implementation part. Okay, so let's first create the dataset. Okay, so from surprise import dataset, from surprise import the reader. So obviously you need a reader for reading the dataset. It's not like pandas data frame that you can read it just the way you were reading it. Okay, also we need pandas spd np. Okay, so we are done with all the necessary imports. So now let's load the movie dataset. Okay, so this dataset is unstructured, so that's why I mentioned that you can use any dataset, but it should have feature like rating, user ID, and the movie ID or book ID. You can even use book rating dataset, anything. Okay, but make sure that it has these three features. Okay, so let's load the data. So dataset dot load, so built-in method, and here we have ml 100k dataset. Okay, so now let's run this. Okay, so when you will be running this for first time, it will ask a prompt, do you want to download the data or not? So you have to input y. So since this is my third or fourth time that I am using this data set, it is not asking me. Okay, so now after that let's fetch the raw rating. Okay, data dot raw ratings. Okay, so let me tell you, so the data set is unstructured, so it is in the form of nested list. So we might need to convert it into dictionary, since dictionary is the only format that our code will be accepting. I mean the recommendation function that we will be creating for the. So if you want to see the dataset, let me show you how to see it. So display a sample of ratings, and the data is in format of user ID. First it is user ID, then it is item ID, or you can even assume as a movie ID or a book ID. Then we have rating and a timestamp. Okay, so timestamp is in the format of Excel, so we need to convert, but for this task we don't need, so let it be like that. Okay, so print raw rating, and let's see the top 20 results. So this is how it looks. So first we have user ID, second we have item ID, and what is the rating that has been given for that item, and the timestamp. Okay, so you can see it is it's a tuple inside a list. Okay, so this is how it looks. I mean, if you want to see the whole data set, you can just print the raw rating and you can see so many data set we have. Okay, 100k data set almost. Okay, so that is what this raw rating contains, ml 100k contains. Okay, now let's start the main part of this project. Okay, so first of all we need to create a dictionary for mapping user and item indices. Okay, so let's do that first. To rating. Okay, so let's create the rating empty dictionary for now, and we will be feeding it uh, uh, over the loop. Okay, so rating dict equal to, the first column will be user, and define the empty list. Same way item empty list, then again rating column with empty list. Okay, now we'll run through loop. So for u comma I comma r in okay, so first of all we also need to do one more thing, that is we need to so out of this data set we need to bring the training set. Okay, and this function provide us I mean this data set function provide us the functionality to directly build the training set by just calling one function, and that is build full train set. Okay, so let's call that. So it's build full train set. Okay, so now run this, and we can even check the type of data type is, so it says surprise training set. Okay, so it's an object. Now we will be calling this train set for u comma I comma r in the train set dot all ratings. So rating dict of user dot append u. Now copy this two more time, I mean paste it two more times. Let's create some space. So replace u with I and then r. Change the user to item and then rating. Okay, now let's run this. Okay, it should be function. So we have our data set ready. Okay, so rating dictionary, you can see for user 0, for user 1, everything is ready. It's in the format of dictionary. Okay, so what has happened here? So let's summarize. So we have initialized an empty dictionary called rating dictionary with 3 key, that is user, item and rating, each having an empty list as its value, and this dictionary will be used to store user, item, rating mapping. Okay, now what we are doing in the next line, this line initiate a loop through all the rating in the training set. for each rating UIR, we are performing, um, I mean, correspond to user index, correspond to movie index, correspond to rating given by the user for the item I. Okay, and that is what we are appending here. And so this is what it does. So I mean, all of the line is appending, uh, I mean, item index I for the, item list within the rating index. Same for others too as well. I mean, uh, the last line is again, so it is appending rating R given by the user U to the item I to the rating list within the rating dictionary. Same for the user. So inside this loop, this line is appending user index U to the user list within the rating dictionary. So that is what it's happening here. Now let's move to the another part of the implementation. Okay, so first let's determine the number of user and item we have, and let's store it in some variable. Okay, determine the number of users and items. So num users equal to train set dot n users. Also guys, I will be doing some projects on this, like 3 to 4 projects on this, and I want you guys to watch it, because the implementation that we are doing is, it's a very high level thing that that can get clear only when you practice a lot. So for that solely reason, I am giving 3-4 videos on 3-4 projects, which will be completely on recommendation system. And I will be using some different type of algorithm, like KNN algorithm is nowadays used for recommendation, because right, I mean, in the KNN algorithm also we have something called distance metric. So how it does, uh, I mean, identify nearest neighbor by using this distance metric that we are using here: cosine, similarity, Euclidean distance, Manhattan distance. Okay, and for that reason, KNN is nowadays used for recommendation purpose also. So we will be using that as well, and for that I will make sure that I have some data ready, because it will be easy for you guys to understand what type of data we should have, what feature we should have. Okay, those regions. So that's why I'm doing for you guys. I mean, I'll be implementing 4-5 projects for recommendation system, and also for other algorithms as well, like random forest I will be implementing few projects, like LGBM I will be implementing some projects. So just stay tuned guys. I mean, I will be sharing as much as possible. So for that I need feedback from you guys, that you guys are liking my videos. If there is something like I'm not going in the right way, you need something else, you need me to explain anything else in my videos, please do comment on videos. I will definitely gonna look at it. And since I am new to this platform, like I may need some feedback, guidance, how I can improve my videos. So please do give feedback. Any problem you have, any video you want me to implement, I will be happy to do that. But for that you need to comment any problem that you are facing, any challenges that you have. You can directly contact me over email. So here I am writing my email. Okay, otherwise you can just comment in the video section. I will be replying you as soon as possible. Okay, so 1238 at gmail.com, you can email me anytime. I'll be replying you guys within 24 hours of timeline. So that's all. That's all I wanted to give a note, because I have heard some feedback from my existing subscriber, that they told me that I should be doing videos on time series modeling. So I'm preparing for it. So in few days I will be starting the time series analysis as well, and so that if it give me positive vibe that you guys are liking my videos, so it will give me confidence to create more videos, more you know other things, not only on data science but anything you guys can ask me. I mean, I'm a type of stack developer that do multiple jobs. It's not like, so earlier I was into Java development, web development, and then after those things I have transitioned to data science. So nowadays I am more towards data science, but even if you have questions related to web development or software development, you can ask me and I will try to make that video to make you understand. Okay, so that's all. I mean, thanks for listening. Okay, so now what so we have determined how the numbers of user and items we have, and we have stored it. Okay, next thing we have to do is we need to create a rating matrix. So let's do that. The ratings equal to, and it should be of shape number of user and number of item. And first of all we will initialize with zeros. Okay, so np dot zeros of size num users comma num items. Okay, so for user comma item comma rating, in zip the rating dict user, the rating dict of item, the rating dict of rating. Which will be ratings of user comma item equal to rating. So what's happening here is, let's understand. So here what we have done is so basically it will retrieve the total number of users and total number of items from the train set, and we have assigned it to variable called number of user and number of item, and it will count, it will have count of distinct item or user present in the data set. Okay, so this particular line of code we have done to extract number of total number of user and item we have in the data set. Further that what we are doing here is we have created a rating matrix. So this line initialize matrix rating with dimension number of user multiplied with number of items and filled with 0. So it's indented to represent a user item matrix where row correspond to users, column correspond to item, and each cell contain the rating given by the user to an item. Okay, so you can even have a look. Yeah, this is how it looks. Okay, so basically here what's happening, so this loop iterates through rating dictionary which contain user item rating mapping, and for each user item and rating tuple, user represent the user index, item represent the item index, or you can even say movie index, and rating represent the rating given by the user to the item. Okay, and the last line here what's happening, inside this loop, this line assign the rating value to the specific location in the rating matrix correspond to the user row and the item column. So it populates the rating matrix with the user item rating. Okay, so that you can see here. Now let's define the cosine similarity function. Okay, so let's not use the predefined scikit-learn function. Let's create our own so that it will help you recall what was the formula. Okay, so cosine similarity, and you can use other distance calculator metrics as well. So for now I am using cosine similarity. Okay, so the formula is return So it is a dot matrix of u and v divided by normalization of u and v. Okay, so np dot matrix of u comma v, which is a vectors, two vectors, divided by np dot linear algebra dot norm of u multiplied by np dot linear algebra dot norm of v. Okay, and that's all. Let's run this. So basically what it does, it calculates the cosine similarity between vector u and v, and this function computes the cosine similarity between vector u and v using the dot product and the norm of the vectors. Okay, so the double line that you used to see in the formula is this is how we achieve here in Python. Okay, so we have done with the cosine similarity as well. Okay, okay, now what we need to do is we need to create a user similarity matrix. Okay, so let's do that. Def user similarity. So you can see one more thing that I do is basically whenever I write code, I use I create functions, because it is it is simple to understand, and when you do hard coding, it is very hard to understand why this code has been used, why this code is not used, and there is multiple reason. Hard code is a bad practice, and going through user defined function, it is a very best practice to go with, and writing comment is also a good practice. So that's why every time I write code, I never forgot to write the comments. Okay, so that is the reason I usually whenever I write code, I create function, not most of the time I ignore doing hard coding. Okay, because it is a very bad practice. That's the thing. Okay, so let's create this user similarity matrix, and here we will be passing ratings. Okay, so first of all, we need to store what is the number of user we have. So number of users equal to ratings dot shape of 0. Then let's create the similarity matrix. Matrix equal to np dot zeros of num users comma num users. Okay, and then for I in range of number of users, if so we'll check on condition. If I not equal to j, in that case in the similarity matrix, position where I and j is there, rating of I comma ratings of j. Okay, and we will return the similarity matrix. Okay, so what we have done here is so basically we have defined a function with name as user similarity matrix, and I mean, so it will have it will compute the similarity matrix among user based on the rating matrix. So the very first thing that we are doing is we are retrieving the number of users from the rating matrix, and then after that we are initializing an empty similarity matrix of size number of user into number of users, which will store pairwise similarity between users. And after that we are this loop iterates over each row in rating matrix, and then again of I haven't defined the j, so j should be I mean again in it should be for j in range of num users. It is the same loop. Okay, now let me tell you why I have done this. So this loop will iterate through each user in the rating matrix, okay, the I1, and the J1 is the nested loop iterate over each user again to compare the other user. Now you got it right. Now why I'm checking this condition, because this condition will ensure that the similarity between a user and themselves is not calculated, as it will always be 1, indicating maximum similarity. Okay, after that, in this line, for each pair of distinct user I comma j, it computes the cosine similarity between their rating vector and the stored and stores the similarity score in the similarity matrix. And finally, we are returning the similarity matrix that we have computed, which will contain user similarity score based on the rating. Okay. Now next thing we have to do is uh, let's call this function and let's create the user similarity matrix. Okay, so let's run this. Okay, if okay, now let's create the user similarity matrix, which will be user similarity matrix, and we have to pass the rating, okay, that we have created here. So let's run this, and we'll have it will have our user similarity matrix ready. Okay, now after that what we need to do is we need to create a function that will predict rating for a user based on the user similarity. Okay, so let's create that function. So predict a rating for a user based on user similarity. Okay, so def predict user rating, user id comma item id comma ratings comma user similarity matrix. Now first of all we need to have shapes. I mean what is the size of number of user and number of item do we have. Okay, so let's do that. Let's store into these variables. Ratings dot shape of 0. Okay, now initially let's create a one variable that will store the prediction rating for now to be 0.0 as of now, and then similarity sum to be 0 as well. Okay, so I'll tell you why we have created these many variables. Now first of all what we need to do is we need to run a loop. So for I in range of number of users we have, and we'll check a condition if I not equal to user id and not equal to 0. Now let's update the prediction rating plus equal to user similarity matrix. Okay, user id of I multiplied with ratings of I and item ID. So sim sum, let's update the sim sum also. So it should be absolute value, not the float. If float, it will throw an error. Okay, so let's take np.absolute of user similarity matrix, user ID and ith position. Now let's check one more condition here. If sim sum equal to 0, then it should return 0, because if there is no similar user that have rated the item, so then again uh, it will throw an error if we not handle it carefully. Otherwise it should return prediction rating divided by sim sum. Okay, so let's understand this code. So basically, first of all, what we are doing here is we are creating a function, prediction user rating. Okay, so what it does is it takes four argument: user ID, item ID, rating and user similarity matrix that we have created here. Okay, so the very first thing that we are doing here is we are retrieving the number of user from the rating matrix, and then we are retrieving the number of items from the rating matrix. After that, we are initializing the predicted rating for the user on item to be 0. Same way, we are also initializing the sum of similarity, so to 0, and it will be used for normalizing purposes. After that, we this line iterates through each user in the rating matrix, and this condition is basically checking. So check if the current user is not the same as the target user, and whether the current user has rated the item, then only proceed, otherwise not proceed. Okay, so after that we are updating the prediction rating variable. So it calculates the predicted rating by adding the similarity between the target user and the current user. So after that, what we are doing is here, and okay, and it is also multiplied with the rating given by the current user to the item this. Okay, after that we are also updating similarity sum. Okay, so this will calculate the sum of absolute similarity between the target user and the other user to see the uh, you know how it is similar. Okay, and then again this value will be used for normalization purpose. And so this condition is checking if there is no similar user who rated the item, it will return 0 to avoid the division by 0 error. Okay, so if we will have 0, it will throw an error, that is division by 0 error. And lastly, returning the predicted rating normalized by the sum of similarity. Okay, now there is only one function that we need to create, that is recommend item. Okay, so let's create that function as well. Generate a recommendation for a user. Okay, again it will take user ID, the ratings, user similarity matrix and number of recommendation you want to give. Okay, so let's say I want to give three recommendations. Okay, you can change as per your inconvenience. Okay, convenience. Okay, so now let's create a user rating variable. Okay, which will be ratings of user ID, and then let's also find out unrated items. Okay, equal to np dot where user rating equal to 0, and I need the 0th position. So it will basically find out the unrated items. And after that, let's create a empty list for storing the predictions. For item id in unrated items, let's update the prediction. So we'll call the predict user rating, and here we will pass our user id comma item id comma rating comma user similarity matrix. Okay, and then we'll append the predictions. For that item, now let's sort it. So predictions dot sort key equal to lambda x of 1 and reverse equal to true. So this line is basically by rating order. Okay, so after sorting, we need to return, right? So return item id for item id in predictions, whatever the number of recommendation you have asked. Okay, and we are done. Okay, so we are done with all the function that is needed to achieve this result recommendation. So let's now try it with an example. Okay, so what we can do is let's get the recommendation for the user 1. Okay, and here we'll pass the user id, that is 0, the ratings, as well as user similarity matrix. Okay, and we are done. So let's print it out. Okay, so let's run this. Okay, so we have our rating for the user 0. You can also try with other users, let's say user 1, user 2, and you can see that this is how it works. Okay, you are getting the recommendation. So now how to understand this recommendation or how to convey message. So the output signifies the recommendation item for the user 0 based on the implemented collaborative filtering method. So in this case, these are the item IDs that have system suggested the user might like. So each number represent an item from the data set. So for instance, if this data set represent movie, these numbers would be corresponded to particular movie in the data set. So this recommendation system utilizes a collaborative filtering technique, leveraging similarity between user rating to suggest the item. So the algorithm calculates the similarity between the target user, in this case user 0, and other user in the dataset, and based on the ratings given by the similar user to the item that is user 0 hasn't yet rated. So it suggests a few items that user similar to user 0 has liked. So the item IDs 103811301150 are the top 3 recommendation for user 0 according to the collaborative filtering method. So hope you guys have understood how to implement collaborative filtering and how the data should be fed to these functions, and the core behind the recommendation system. This is how Amazon, Flipkart, you know Instagram, feed us recommendation based on our clicks, things that we have liked, things that we have shortlisted, is our in our wish list. By considering all those things. Okay, so I hope this video was very informative for you guys, and if you have any question, please ping in the description box, or you can just email me, and yeah, that's all. And let me know guys if I need to make changes to anything, and the way I convey messages for any uh, uh, you know method. If you want anything specific, you can even put in the description box. Also guys, the code that I have just wrote, you will find a link for the GitHub, and you can directly go there and download it, and you can even try out um, different distance calculation metric, and you can play with number of recommendation other parameters, and you can see how does it affect the recommendation model. So hope you guys like this video. Please do subscribe, do like my videos, and please comment if you have any queries. And yeah, thanks for that. On this video we will be implementing content based recommendation system. Previously we have implemented collaborative based filtering recommendation system, and on that we have used several methods like predicting user rating, then using similarity matrix and cosine similarity to give recommendation to a user based on the rating. Now similarly we will be implementing this content based recommendation system, which will be similar, but the way we have implemented it can be somewhat different. Okay, and here we will not be using the data set that we have previously used, since it didn't had feature name on it. So we will be creating our own data set on this, so that it will be clear how uh, one user profile is recommending another book or movie based on cosine similarity, and the feature that we will be creating on this. Okay, so let's get started with the implementation part. And here we will be using something called count vectorizer as well, and while coding I'll explain why that is the case. Okay, so first let's import all the library that is needed for this implementation. So first will be numpy as np, then pandas as pd. Okay, so from sklearn dot matrix dot pairwise import cosine similarity. So guys, I have implemented this cosine similarity function in the previous video manually. If you want to know the formula, you can just go back and watch the video, the previous one, where I have implemented it manually. But this time let's make the video short, and let's use as much as possible the functionality that scikit-learn provides. Okay, so from sklearn dot feature extraction dot text import count vectorizer. Okay, so yeah, we are cosine similarity. Okay, yeah, so we are done with the importation part. necessary libraries. Okay, now what we will be doing is we will be creating the data set. Okay, so let's create the data set. So sample book data, and let's add a seed for reproducibility, because every time we will run it will give different results. So that's why let's set a seed for it. So np dot seed dot, okay, random dot seed, let's make it 42. So let's create a three list: title, genre and author. Okay, and then all these three lists will be feeded as data to the data frame. So let's lastly we'll create the data frame out of it. So let's create the three list first of all. Okay, and let's create 30 data point for now. You can create as much as possible, or even you can use some data set if you already have, or you can download it from Kaggle, because uh, I mean it's a dump of data set you can find there for this movie rating or product based recommendation data set. So you can use that here as well, and make sure that the feature that we are using here, um, I mean you should implement all those features accordingly, and the main feature will be again rating. Okay, and based on that obviously it calculates the distance out of it, and it recommend based on that. Okay, so not only rating but also different factors, so we'll be discussing further in this video. Let's do that. So first of all, let's create the data set. So for I in range of 30, then we will have genres. So np.random.choice, let's say we have 4 different type of genres. First fiction, second non-fiction, third mystery, fourth let's say science fiction. Okay, and we need to also make sure the size is 30. Same way for author, np dot random dot choice, author let's say X. Let's create 3 authors: author X, author Y and author Z. Okay, again we need to feed the size to be 30. Okay, so we are done with all the list creation. So this is like a list comprehension method. Okay, and let's now feed all these 3 lists to the data frame. So let's create a data with the name books data. Okay, so pd.data frame, and inside it let's create 3 columns: title, and its data to be this. Then let's create another column that is genre, and for this our data will be this, and lastly the author. Okay, so we are done with the data frame. Let's run this. uh, okay, now if you want to look the data set, you can just print it out. Okay, so this is how it looks. Now let's move to the another part of this implementation. Okay, so let me explain what's happening here is, so we have set the seed for numpy random numbers generator to 42, ensuring reproducibility for random results. After that, here it generates a list of book titles using list comprehension, and it creates book title like book A, book B, book D, like that up till book Z, and it will create 30 data point for us. After that we have genres. So we are creating array of 30 randomly chosen genres from the provided list: fiction, non-fiction, mystery and science fiction. After that we have author. So again same thing, so it generates an array of 30 randomly selected author from the given list: author X, Y and Z. After that we have created a data frame named books data. And um, I mean this data frame will contain three columns: title, genre, author, where each column represents the book title, genre, author respectively. Okay, so in summary, this code snippet will create a data set of 30 books, each with a randomly assigned genre, author, forming a data frame named books data. Okay, so now let's move to the another part of the implementation. So what now is we'll create a feature. Okay, so I'll create one feature. You can create as much as possible you can think of. Okay, so combine text features for each book. Okay, so let's create a function for it: def combine features, and here we'll pass the row, and it will return row of author concat with space row of genre. You can include as much feature uh, as possible based on uh, your understanding of whether that feature will be useful or not. So I mean it's up to you. So I'm creating just one here. Okay, let's run this function. Now let's create that feature inside our data frame, already created data frame. So we'll just add one column here. Okay, so how to do that? So books data of uh, the name of the column that you want to create. So I want to create it with the name combined features. You can give as you know based on your easiness. Then books data dot apply, so I am using applying function, and then you need to pass the function as well as the axis. Okay, so function and axis will be 1. Okay, so first of all we have created a function combine feature, which will uh, take a row from the data frame as the input, and it will return the concatenated author and genre column in a row with a space between, creating a combined string that represents the feature of the book. Okay, and after that this particular line applies the combined feature function row wise across the book data frame, and generating a new column named combined feature that hold the concatenated string. Okay, so now next thing is we need to use count vectorizer to convert this textual data into matrix of token count. And so for that, let's initiate count vectorizer instance. Okay, so use count vectorizer to convert textual data into a matrix of token counts. Okay, so vectorizer equal to count vectorizer, and then let's create a feature matrix. So this will be called as feature matrix, which will be uh, you know which we need to transform for the feature that we have created. So let me explain that. So first let's write the code. So vectorizer dot fit transform, and we need to pass the feature that we have created. Okay, so books data of combined feature. Okay, let's run this. Okay, so the error was came because I didn't run this line, so that's why. Okay, so I have run it, and now I think the code runs successfully. Okay, now if you want to check feature matrix, you can't directly check it because it is in, you know, sparse format. So if you want to, you know, see what it contains, you can do something called print feature matrix. Okay, let's say 10 rows. Okay, we need to convert it to array. Okay, and now you can see, so this is how it will be looking like. Okay, so now so what that vectorizer is doing is, first of all, we are initializing an instance of count vectorizer from scikit-learn, which converts the text data into matrix of token count. So this particular line, what happening here is, it using the count vectorizer to transform the combined feature column from the books data frame into a feature matrix. So each row in the matrix represent a book. Okay, so the row represents the book, and the column represents the tokenized word in the combined text feature. Okay, so hope that is clear. And now what we need to do is we need to create a cosine similarity between the books. Okay, cosine similarity, I think you guys already know what it is. It calculates the distance between two vectors. Okay, so let's do that. Calculate cosine similarity between items, or you can even call as books. Okay, so item similarities equal to cosine similarity, and you have to pass the feature matrix, and let's run this. So now we have similarity between all the books. Now let's create a function that is get the recommendation, and which will tell us for a given user profile what all book it has recommended based on the distance. So let's create that function. So def get book recommendation, and here we'll pass the user profile. User profile is nothing, just for which user you want to see the recommendation. Okay, then item similarities that we have just created. Okay, so what's happening, so in item similarities, it computing the cosine similarity between books based on their textual feature, and it calculates the cosine similarity matrix using the cosine similarity function, which compares the feature vector of the books and returning a matrix of pairwise similarity. Okay, that is what it has. Now let's uh, create complete this function, get book recommendation. Okay, so first of all we need to filter for the user profile. So basically this user profile we want to filter because we want all those genre and author that this user has you know has been using, or you can say it has rated. So and this implementation is also I have implemented in the previous video. You can have a look. I mean, the function will be similar but not completely same. Okay, so preferred books equal to books data of genre should be equal to user profile of genre. Okay, so we are making sure whatever the query is, the filtered data should have only that related data. Okay, and books data of author equal to user profile of author. Okay, and we are done with the filtering part. Now let's move to okay, so there is one more thing that that need to be coded. So there can be some cases, okay, where for the given user there is no, you know, there is empty result, okay, so there is no data for that user, and that time we need to handle that cases in a way that, you know, it doesn't cause the code to break, okay. So for that, let's simply write if preferred book is empty, in that case return no matching book found in the dataset for the user profile, okay, for the given user profile. Okay, so we have handled it carefully. Now let's gather recommendations, okay. So so for that, let's create an empty dictionary. So recommendations. So for index comma book in preferred book dot iter row. So this iter row function basically iterate through one row at a time. Then let's create a book similarities, which will be item similarity of that index. Then let's gather similar books, which will be list of books data, location where arg sort of minus book similarity 1 up to 4. Okay, so there is one more thing that we need to define, you know, number of output. So for now let's be at 3, okay. So this is this will return 3 books as the recommendation, okay. So you can change as per your convenience. Then what I need is, I need title, okay, title of that book. So we have got the similar books. Now let's you know, update the recommendations. Equal to similar book. Now let's return the recommendations, okay. So we are done with the recommendation function as well. So let's understand what's happening here is, so first of all, this preferred book, again, like I said, this line filter the book data, so the data frame based on the user preference, especially you know, by matching the genre and author attribute from the user profile. Now we are handling some case. So if there is no book matches the user preference, if so, it will return a message indicating that there is no matching book for the user profile. And after that, we are initializing an empty dictionary to store book recommendation, okay. And further that, we are iterating through the filtered book that matches the user profile, and this will, you know, retrieve the similarities for the current book in the loop for the item similarity matrix, which contain pairwise similarity between the books. And this particular line is basically you can understand it as a it calculates the indices of book sorted based on the similarity score, which is descending order, okay, and excluding the most similar books. So hence it is 1:4, okay. After that, so we are retrieving the title of most similar book to the current book based on the similarity score, and the store them in a similar book variable. Later, what we are doing, we are, you know, assigning the list of similar book to the current book title in the recommendation dictionary. Lastly, we are returning a dictionary containing the recommendation for each book that matches the user preference with the similar book listed for each book title. Okay, so now let's try out one example how it is doing. Okay, so for that, let's prepare a user profile. Example user profile, and user profile should look like this. You need to pass genre and author. It should be in the form of dictionary, okay. let's say I want it to be gender to be mystery, okay, and author X. So now let's get the recommendations. So user recommendations equal to get book recommendation. Okay, let me restart the kernel. I am getting some unknown, you know, variables. It might be previously ran variables that have not got reset because of that. So let's pass the user profile, then obviously book data. Okay, I have to run it again. Books data, and then item similarities, then print the output. User recommendations. Okay, so let's run this. Okay, so we have got recommendation for the user profile that we have prepared. So let's understand the output, what it is saying. So the output says this book A having book N M L, okay, and then again book E have book N M L, okay. So this suggests that that for the user who have shown interest in book A and E, the recommendation system suggests book N M L is the recommendation. So this recommendation are based on the user profile, indicating the user who likes book A and book E might also like suggested book due to similar characteristics, content and user preference. Okay, so hope you guys understood how to comprehend the output. Okay, so that's all in the content based recommendation system. Hope you guys have learned how to implement it. Now in the next video we will be implementing hybrid system, which is the combination of collaborative and content based filtering. Okay, so see you guys in the next video. Thanks for joining.